We're going to talk about math, but probably not in the way you're used to. Let's start with a sound. In fact, a sound you already know really, really well.
You know that song that comes on and you just start nodding your head? The one where the beat just locks into this perfect groove and doesn't let go? It's predictable, right? That same rhythm just repeating over and over again?
Well, believe it or not, that feeling, that steady, predictable sound, that's the feeling of a core mathematical concept. You've been listening to linear functions this whole time, and you didn't even know it.
So how on earth can a steady beat explain something from algebra class? Well, it all comes down to one simple thing: repetition.
Think about the production on a TI track. The hi-hats, the snare, the kick drum, they lock in and establish a pattern that repeats perfectly, bar after bar after bar. It doesn't all of a sudden speed up or slow down. It's basically a straight line of sound.
And that's the crucial link right there. That steady audio pattern you can hear has a direct visual equivalent in math. The consistency you feel in the music is the exact same as the straightness you'd see on a graph. No curves in the sound means no curves in the math.
Okay, so let's take that feeling, that idea from the music, and let's give it its proper mathematical name.
And here we are. In the world of math, we call that steady repetition linear. It's all about a constant rate of change. It doesn't matter where you are in the function, the next step is always the same size as the last one. Always. It's really that simple. It's the same step leading to the same increase, creating the same pattern over and over. It's just like a drummer who's perfectly in the pocket, hitting the kick on the 1 and the snare on the 2 every single measure without fail.
And that's the big visual payoff. Because that change is so predictable and so constant, when you actually go to plot it on a graph, you don't get a crazy squiggle or a big parabola, you get a perfectly straight line.
Now, this next part is maybe the most important takeaway of all, because this is all about shifting your perspective on what doing math even means. I want you to forget about the numbers for a minute. Seriously, we're not solving for x, we're not trying to find y. That is not the goal right now. And you can definitely forget about the equations. No y equals mx plus b or any of that stuff. We're stripping all of that away to get to the core, fundamental idea. The only thing that matters is this. Can you recognize the behavior? Can you spot that steady, repetitive, predictable pattern? Because if you can do that, you already understand the essence of a linear function. So here's a super simple checklist. To know if something is linear, you just have to ask yourself, does it feel steady? Is the pattern even? And if the answer is yes, and there are no curves or bends, then yeah, it's linear.
And this is the big reveal, right? This isn't some strange alien concept you have to learn from scratch. You already have the intuition for it because you've been hearing it in music your whole life. And I absolutely love this point. The math itself hasn't changed. What changed is your frame of reference. By connecting it to something you already get, like a steady beat, the whole concept just becomes clear. So let's take this one step further. Now that we can actually recognize the pattern, what does the sound itself mean?
Okay, we've established our foundation, a consistent repeating pattern, our steady beat that translates directly into a straight line on a graph. We've got that locked in.
But here's the next question. What about that beat? You know, whether it's a fast, intense beat or a slow, laid-back one. What part of the math is that feeling? What does the nature of this sound itself represent? It represents the slope. The intensity and speed of that steady beat you're hearing, well, that's just the audio version of the steepness of the line. And that is exactly what we're going to break down next.
So, let's end on this thought. This isn't just a clever trick. It's a completely new way of thinking. Because if you can truly learn to hear the patterns in math, there's absolutely nothing you can't understand.